Good morning students, welcome back to our digital classroom once again. As I told earlier, today I'll be starting a new chapter, that is understanding quadrilateral. So before starting quadrilateral, I think we should know about polygon, because quadrilateral is a part of polygon. So let's begin with polygon. Okay, what is a polygon? A simple closed curved figure made by line segments is called polygon. You remember, simple closed curved figure, and also it is made by line segment, then only it will be a polygon. So I am showing you so many shapes. So are all these shapes polygon? Definitely not. What are the shapes will be polygon and what are the shapes will not be polygon? You just check here. You see I have shown some 3D shaped pyramid, cone, cuboid and some 2D shaped. Okay. So to become a polygon, the shape must be 2D shaped and 2D flat shape. Okay. So among these, what will be the polygon? You just see, whatever the figure is out, those are polygon, and what are the figures still left? These are not polygon. Pyramid is a 3D shaped, it can't be a polygon. Cone also 3D shaped, it can't be a polygon. Cuboid also 3D shaped, is not a polygon. But each part of the each face of the cuboid will be a what? Flat surface, that can be a polygon. But when they join together, it will not be a polygon. Similarly, pyramid also. Okay. Now this shape, it is a simple simple curve. It is not also closed and not made by line 7, so it is not a polygon. It is made by polygon but intersected. It is not simple. Okay. This is also made by polygon but opened. Okay. This portion is not joined. Circle is a closed curved figure, but the circle is not made by line segment. That's why circle is not a polygon. This is angle. It is made by line segment but open. These two ends are not joined. So an angle will not be a polygon. It is also a closed curved figure, not made by line segment, and it is not a polygon. This shape, spiral. Okay, spiral is also not a polygon. This is made by blind segment but open again here. This is not a polygon. So it is semi-circle. Diameter is the line segment, but this is a curved part. It is not made by line segment. So it is also not a polygon. So you have understood what are polygons, what are not polygons. Okay. Now I am coming to next. What are the properties of a polygon? Properties of the polygon basically depends on the number of its sides, number of vertices and number of angles. So on the basis of this, polygons are categorized to mainly two types. One is concave polygon, another is convex polygon. You see here, these three shapes are concave polygon and these three shapes are convex polygon. Why these are concave polygon? Because this is made by the line 7, polygon must. But you see some of the interior angles, these interior angles, okay, is greater than 180 degree. So if any polygon being interior angle greater than 180 degree, then it will never be a polygon. Similarly, this arrow sign, this part also having more than 180 degree, so this is also not a polygon. L here, this is made by this angle is more than 180 degree, so it will not be the convex polygon. Okay, it will be a concave. So plus sign, arrow sign and angle L sign, this will only a concave polygon but not convex polygon. To become a convex polygon, you see, made by line segment and each interior angle is less than 180 degree. It is a square, that's why each angle will be 90. This is a triangle, closed figure, and equilateral triangle, each angle is less than 180 degree. This figure is a pentagon, so angles, each angle is less than 180 degree. That means concave and convex polygon basically depends on the interior angle. if any figure, any shape having more than 180 degree as interior angle, it may be one angle, it may be many angle, so that figure will be a concave polygon, and if it is less than 180 degree, then it will be a convex polygon. Clear? Now, how to find out the number of diagonals of a polygon? So, number of diagonals of a polygon, basically we follow this formula, n square minus 3n by 2. This will I discuss just after one slide. Okay, how to find out the diagonals, number of diagonals of a polygon. So now convex polygon, again we have divided into two categories. One is regular polygon, regular convex polygon, and another is irregular convex polygon. Okay, regular, how will say regular? When a convex polygon where its sides and interior angle will have equal in measure. That means each side will be equal, each interior angle will also be equal. So then it will be a regular polygon. So in case of square, square is a regular polygon. In case of equilateral triangle, it is also a regular convex polygon. But you see this pentagon, sides are equal. Okay, sides are equal, but some of the interior angles, this one and this one, the interior angles are not equal. That's why it will be only a convex polygon, not regular. It will be irregular convex polygon. So, are you clear? Now, I will show a video clip through which you will come to know all about the types of polygon, properties of polygon, and shape of the polygon. And to memorize it, you should just follow this video nicely. Okay.
We need to learn about the specific properties that all polygons have in common. First, we need to know the three parts that make up all polygons. And these parts are sides, vertices, and angles. The sides are just the straight line segments that make up a polygon. And the vertices are the points where the sides intersect. And the angles are formed by the intersecting lines. In fact, in Greek, the word polygon literally means many angles. So all polygons have sides, vertices, and angles. This polygon here has 5 sides, 5 vertices, and it forms 5 angles. The next thing we need to know about polygons is that they're closed shapes. Now, what does it mean for a shape to be closed, you ask? Well, it means that the sides are connected so that there are no gaps. The area inside the shape is separated from the area outside the shape, and there's no way to get from the inside to the outside without crossing a line. It might help to think of a closed shape like a cage. If you put an ant inside the cage, then there's no way for it to get out without crossing a line. But if the shape is open, then there is a way out. So these are all examples of closed shapes, and these are all examples of open shapes. And the important thing to remember is that a polygon must be closed. And the last thing we need to know about polygons is that they're two-dimensional or flat shapes. And that means that all the vertices must lie on the same plane. If any one of the vertices were to move forwards or backwards so that it wasn't on the same plane as all the other vertices, then it wouldn't be a flat shape anymore. Flat shapes are also called planar shapes because all of their points are on the same plane. And even though polygons themselves can't be 3D shapes, you can use polygons to make 3D shapes, like a box, for example. The box is not a polygon, but each of its flat sides is a polygon. Alright then, we now have a specific definition of a polygon. A polygon is a multi-sided shape that has sides, vertices, and angles. A polygon is a closed shape, and a polygon is a two-dimensional or a flat shape. And now that you know that, it's time to play Polygon or Not a Polygon. Now here's your host, me! Thank you. Alright, now the rules of the game are simple. I'm going to show you a shape, and you tell me if it's a polygon or not a polygon. Are you ready to play? Our first shape is a square. Is a square a polygon? Yes! The square has 4 sides and 4 vertices, and it's a closed 2D shape. So it is a polygon. And next we have, not exactly sure what to call this, but Is it a polygon? Nope. It's close, but because it's an open shape, it can't be a polygon. All right, what about this one? Polygon or not polygon? Yup, it is a polygon. Even though the sides aren't all the same length, it is a closed, 2D, multi-sided shape. In fact, if you count, you'll see that it has 7 sides. What about this one? Is a circle a polygon? Well, it is a closed 2D shape, but how many sides does it have? Now that's the problem. A circle doesn't have any straight sides, vertices, or angles. It's a curved shape, so it's not a polygon. Oops. Next, we have a star shape, just like me. Is it a polygon? Yup. It has straight sides and vertices, and it's a closed 2D shape. That means it's a polygon. And what about this one? Right you are. This is not a polygon. It's a dog. Here's an interesting one. It's a closed 2D shape that does have straight sides and vertices, but it also has this curved part here. Can it still be a polygon with that curve there? No! The curved part disqualifies it as a polygon. Polygon has to have only straight sides, so this is not a polygon. And what about this guy here? Is this a polygon? Well, it is just straight lines, but 2 of those lines cross. And if any lines cross, it can't be a polygon. Plus, he has this big open end here, so this guy is definitely not a polygon. And last of all, what about this one? Right you are. This is not a polygon, because it's a 3D shape. It's made from polygons, but the whole shape is not a polygon itself. Well, that's all the time we have for this week. Join us next week as we decide, is it bigger than 1? Okay, so after playing that game, you should have a really good idea of what a polygon is and what it is not. The last thing I want to mention is that some polygons have special names depending on how many sides they have. Here's a list of the most important ones to know. 3-sided polygons are called triangles. Triangles are so important in geometry that they'll get a whole video of their own. 4-sided polygons are called quadrilaterals. Wow, now that's a fancy math word. But it helps if you just remember that the first part, quad, means 4. Quadrilaterals are shapes like squares, rectangles, and parallelograms. They'll also get a video of their own. 5-sided polygons are called pentagons. 6-sided polygons are called hexagons. And 8-sided polygons are called octagons. By the way, polygons that have 5, 6, 8, or however many sides like this are called regular polygons if all of their angles are equal, and irregular polygons if their angles are not equal. Of course, there are a lot more polygons than that, but you probably won't need to know their names. As long as you know what polygons are and how to identify them, then you're ready to move on. The exercises for this section are pretty easy, so no excuses. Good luck. Thanks for...
I think you have clearly understood what is said. What is polygon, what will be the shape of polygon, what will be the types of polygon, everything is clear. Only little bit correction. He said regular polygon when the interior angles only equal, but not, it is not like that. Interior angle and each side should be equal, then only it will be a regular polygon. Understood? Coming to next. As I told earlier, how to find the number of diagonals of a polygon. So you see, this is the formula to find out the number of diagonals of a polygon, n square minus 3n by 2, where n refers to number of side. Say one figure, triangle. Okay, what is diagonal? Then first you have to know what is diagonal. Diagonal is a line segment that joins two alternate vertices. Suppose if I start from here, so this will not be the alternate, this will be after one. Alternate position is this, but if we draw diagonal here, it will lie on that line segment only. So, and if we start from here, so the diagonal will lie on this side only. If we start from here, the diagonal will lie on this only. So in case of triangle, we will not be able to draw any diagonal. So even if we follow this formula, n square is minus 3n by 2, so still you can get the number of diagonals of a triangle is 0. How? 3 square. 3 n is equal to 3. 3 square is 9. 9 minus 3 into n is the 9. 9 minus 9 is equal to 0. 0 divided by 2 equals to 0. So in case of triangle, there is no diagonal. Are you clear? Now, what about the square? So in case of square, if I start diagonal from here, alternate position will be here. Okay. So one diagonal. If I start from here, alternate position will be here. Okay. 2. If I start from here, alternate position will be here, already drawn. If I start from here, alternate position will be here, already drawn. So in case of square, the number of diagonals is 2. If we apply this formula, n square minus 3n by 2, where n is equal to number of sides. So 4 4 is 16 minus 3 into n, 3 into 4, 12. 16 minus 12 is equal to 4. 4 divided by 2 is equal to 2. That means in case of square, number of diagonals is 2. Now, what about the pentagon? So, in case of pentagon, suppose if I start from here, the alternate position will be here. Okay, 1. Then another alternate position will be here, 2. And if I start from here, it will lie on this line segment. I cannot draw any one. So now if I start from here, so then total number is 4. Then another 5. If I start from here, 2, that is 4. If I start from here, it will be 5. If I start from here, so already it is done. If I start from here, already it is done. So in case of pentagon, I can draw only 5 diagonals. You can apply this formula also. Pentagon means 5. 5 square is 25 minus 3 into 5 is the 15. 25 minus 15 is equal to 10. 10 divided by 2 is equal to 5. That means in case of pentagon, number of diagonals is 5. Okay. Now another example, hexagon. Suppose I like to draw diagonal from here. So one diagonal, alternate position is here. 2 diagonal, alternate position is here. 3 diagonal. Okay. Now if I start from here, this one, this vertex, alternate position will be this one. 4, 5, 6. If I start from here, already 1 is drawn. So then this 6, 7. If I start from here, alternate position is there. 8, 9. Already it is drawn. Okay, total number is 9. Okay. Now if I follow this formula, hexagon means 6. 6 is 36. 36 minus 3 into 6 is 18. 36 minus 18 equals to 18. 18 divided by 2 is 9. So in case of hexagon, number of diagonal is 9. Clear? Any doubt? So you can follow an activity also from pen and paper method also. You can find out your number of diagonals and you can follow the formula also. But in exam, if it is mentioned draw the number of diagonals with the help of diagram, so you have to show your diagram how you can draw it. Or simply if it is an objective type question, find the number of diagonals of a heptagon, octagon, nonagon, decagon. You replace the n. N equals to number of sides. Okay, that will be the number of diagonals of a polygon. Now I am coming to one of the property that I like to prove, and also I like to have an activity also. Earlier I had an activity on Pythagoras theorem. This will be the activity on x triangle property. You see in the triangle, in case of triangle, it is equilateral triangle I have drawn. If I extend any one of the sides, okay, so exterior angle is there. So since it is a regular figure, so inside angle is 60, inside and outside always will be linear pair. Okay, so 180 minus 60 is 120. In each case it will be 120. Similarly, a regular figure square, okay, it is a square. So outside, if it is a 90 degree inside, then outside will also 90 degree, 90, 90, 90. Okay, so it is a regular pentagon. Each interior angle is mentioned 108. Then outside angle will be, okay, 180 minus 108, that is 72. So in each case, if interior angles are equal, then exterior angle will also be equal. It will be possible only if the figure is polygon, a regular polygon. Okay, regular convex polygon. Now I'll show a animated clip. So here you can see if I cut the exterior angles of any polygon, regular polygon or any polygon, regular or irregular, any polygon, and merge at a point, we'll see it will complete a circle or it will lie around a circle. Okay, like you see triangle, if we merge all the angles outside at a point, it is forming a circle, and we know the sum of angle of a circle is 360 degree. So if in case of pentagon, still it will be a circle, so total angle will be 360 degree. In case of heptagon, if I merge all the angles at a point, okay, exterior angle at a point, it will be 360 degree. So exterior angle of a polygon is fixed, convex polygon, not concave. Forget about the concave. It was only a type of polygon. We are talking about the convex polygon only, regular, irregular. Okay, so this. Have you understood? Exterior angle at any type of convex polygon, if you add, it will form 360 degree, no change. Okay, have you understood? Okay, if you have not understood, I have another one instrument to prove it. I am showing one video clip. From here you will come to know how exterior angles, okay, adding together it will form 360 degree.
Hi, so today we are going to find the sum of exterior angles of a polygon using visual method. So for that I am going to draw a polygon. So these are the 2 points. Let this be the third point, this be the fourth point, and this be the fifth and the final point, right? So we have a 5-ish polygon. And what we do next? Yes, next
Listen
we extend
carefully.
these
You have to
lines.
perform this
So I'm going
activity
to extend
at
all
home
these
on a
lines
chart paper.
towards right. So this will be the extended line, right? And now if I extend this line, this will be the extended line, right? And now if I extend this one, it will come somewhere over here and it will look something like this. And then let me extend this line, so it will look like this. And then if I extend this line, it will look something like this, right? And now let me name these angles. So let this be the first angle, this be the second angle, this be the third angle, this be the fourth angle, right? And let this be the fifth angle. Okay, and what we have to do next? Next I am going to cut these angles one by one and assemble all of them in such a way that their vertices coincide at one point, right? So first let me cut angle number 1. So I'll cut it from here, right? Let me move it over here, and next I'll cut like this and assemble it in such a way that their vertices meet, right? And let me erase this extra line which we have got. And if I cut angle number 3, and again I'll assemble it in such a way that their vertices coincide at one point, right? And now it is the turn of angle number 4. Okay, so this is the angle number 4, and again I have to, yes, assemble it at this point, and then I'll take angle number 5, and yes, together they are making a full circle, right? Or together they are making an angle equal to 360 degrees, right? So this also proves that the sum of exterior angles of a polygon is equal to 360 degrees, right? So this was,
I think you have understood very well. If you take an example of hexagon also, result will be same. Now I will perform this activity. You have to follow the same procedure at home on a chart paper. So say I have drawn a pentagon. This is pentagon. Okay, you can draw hexagon, square, anything. Okay, now extend each side outside. Okay, this side. Okay, then it is forming an exterior angle. So in each corner there will be an exterior angle. Mark them 1, 2, 3, 4, 5. Okay, you can use some color also and different type of color. Okay, angle 1, angle 2, angle 3. For all angles you use 5 different colors. Okay, now take a point on a chart paper, draw a point on a chart paper and cut the angle one by one and paste it on the circle, on this point, okay, and see what is the shape is coming. First I will cut angle 1 and paste it here, angle 2 cut and paste it here, angle 3 cut and paste it here, angle 4 cut and paste it here, angle 5 cut and paste it here. You will see all the angles are forming a circle, or we know another property also is sum of angle around a point is 360 degree. Also sum of angles interior angle of a circle is, total interior angle of circle is 360 degree. Both way you can explain, okay. So this activity you have to perform at home on 1/4 chart paper, and as soon as the school reopens you will show me this activity, okay, along with the previous one also, because it will carry marks. Take it as a subject enrichment activity also, very interesting activity, you can do easily at home. Clear? Now what about the interior angles property of a polygon? So total interior angles of a polygon is n minus 2 into 180 degree. Total interior, it may be regular, it may be irregular. Total interior angle is n. N refers to what? N refers to number of sides. Say a triangle, okay, what is the number of sides? 3. 3 minus 2, 1, 1 into 180, 180. That's why total interior angle of a triangle is 180. This way you can apply any type of polygon, triangle, square, pentagon, hexagon, heptagon. Result will be what? Total interior angle. Okay. Now when the figure is regular, okay, when the figure is regular, then only you can apply each interior or each exterior angle. So each exterior angle, how will you find out? You know total exterior angle is 360 degree. So if you divide it by number of side, you will get the each exterior angle. If you divide it by exterior angle, then you will get number of side, vice versa. Okay. Similarly here also, when the figure is regular, so then each interior angle will be first total interior angle n minus 2 into 180 degree divided by number of side will be each interior angle. So when interior angle is given, you can find out the here interior angle is given, then number of side you can find out by forming an equation here, okay, the regular. Now you see here why the interior angles getting increased when the number of side is increased, okay. You see this is the square. The square is a combination of two triangles. If I draw a diagonal, it will divide in two figures. One triangle is 180 degree and two triangle is 180 into 2, 360 degree. That means total interior angle of a square is 360 degree. Say I have taken example of pentagon. Pentagon is a combination of how many triangles? 1, 2, 3. So total interior angle of the pentagon will be 180 into 3. Same way you can total, I am talking about the total. Similarly, we can take a hexagon. Now draw diagonal from one point. This is divided into one triangle, two triangle, three triangle, and five triangle. Okay. So all five triangle, 5 into 180 degree equals to what? You can find out that number, 720 degree. I think it will be okay. Have you understood this part? Interior angle. So interior angle is increased when the number of side increased. Okay, and each angle, interior or exterior, you can find out if the shape is regular. Clear? Now, do you like to make a song on polygon? I have made a song. Just listen. I think it will recapitulate your all those previous area which already I have covered. Okay, listen.
A quadrilateral is a polygon with 4 angles, 4 sides. pentagon up in the air. 1, 2, 3, 4, 5, 6. Draw a heptagon up in the air. 1, 2, 3, 4, 5, 6, 7. Draw an octagon up in the air. 1, 2, 3, 4, 5, 6, 7, 8. Draw a nonagon up in the air. 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw a decagon up in the air. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A polygon is a shape with lines that connect. The number of sides tells us the name of the shape. A polygon is a shape with lines that connect. The number of sides tells us the name of the shape.
I think you have enjoyed the song, and also it will help you to recapitulate the different type of polygon, its sides, number of angles, etc. Okay. Now I'm giving you some tasks as homework. You remember it. Today I'm not going to send you any answer. I'm just explaining the question. You will do at home. Okay. First question is, how many diagonals does each of the following have? A convex quadrilateral. You just follow the formula n square minus 3n by 2. You apply in all cases, you will get the number of sides. Here question is draw and calculation. Drawing and calculation both you have to show. So you have to mathematically, numerically you can find out the number of diagonals and you draw on a paper. Okay. You will draw a quadrilateral and try to find out how many diagonals it will have. Okay. The next question is, what is the sum of the measure of angles, interior and exterior both, of a convex quadrilateral? Okay. What will be the total interior and exterior angle of a quadrilateral? You have to just follow the formula. Will this support hold if the quadrilateral is concave? I told you concave is just a polygon we come across. Okay. But we will not discuss anything about concave. So what about the properties of convex polygon? It cannot be applied on concave polygon. So this answer will be like this. What can you say about the angle sum of convex polygon interior? Convex polygon, what is the formula? 7-sided convex polygon, what will be the number of side angles, total angles? 8-sided polygon, what will be the total angle? 10-sided polygon, what will be the total angle? 12-sided polygon, what will be the total angle? So you just replace n by writing the number of sides. You will get it. What is a regular polygon? I discussed regular polygon to become a regular if sides and each interior angles both are having same measure. Okay. State the name of the regular polygon. 3-sided, first 3-sided regular polygon is what? Triangle. 4-sided regular polygon is what? Square. And 6-sided, there is no special name. It will be named as regular convex hexagon. Regular hexagon or regular convex hexagon. Okay. Find the measure of each exterior angle of a regular polygon. Exterior angle, you find out the exterior angle. I told you exterior angle is fixed. If we divide it by number of sides, you will get the each angle. Okay. So if 9-sided, then divide 360 by 9. If 15-sided, 360 by 15. If 6-sided, 360 by 6. Okay. This way you can find out what will be the measure of each regular polygon exterior. Okay. How many sides regular polygon have if the measure of exterior angle is? I told you earlier also, if we divide by degree each angle by degree, so then you will get the number of side, and if you divide it by side, you will get the number of measure of each exterior angle. Same way interior angle, if we divide it by 365, in degree is equal to 365, follow this formula, you will get each interior angle formula, you will get the number of side. What is the maximum interior angle possible of a regular polygon? Why? What is the minimum interior angle possible of a regular polygon? So what is the first regular polygon? Triangle. Which type of triangle? Equilateral. Its interior angle is what? 60 degree. Okay, minimum is 60 because less than 3 figure we cannot make a polygon. Okay, so minimum is 3. If minimum is 60 degree, what will be the exterior angle there? I told you exterior and interior always will form a linear pair. So 180 minus 60 is 120. So in case of regular polygon, minimum maximum exterior angle, first polygon will be 120 degree. Clear? This is all about the today's homework. If you have not understood, play the video once again. It will help you a lot. You can do it easily. Okay, so no more today. We will be meeting on Thursday again. On that day I'll discuss about quadrilateral. Okay, till then, bye bye students.